Alrighty guys, so I started this video earlier and I got interrupted, so we're going to try again. So in our table of contents, today we are going to talk about solving compound inequalities. And really what a compound inequality is just more than one. It's almost like a compound sentence that we talk about in English. Like in English class, a compound sentence is like two thoughts connected by and or. And the same thing is true with compound inequalities in math. So today we're going to look at solving compound inequalities connected with an and. So it's two inequalities, and in between them we have the word and. So we're going to do that on 33 and 34. You guys should already have our and on 33. And then on 34, we're going to add a little bit and do a couple problems here. So let's get started. When we are talking about an and inequality, what we're really talking about is two inequalities happening at the same time. So this one and that one. And so really what that means is we're looking for where the inequalities overlap each other. So it's all about how on a graph the lines overlap. So our number lines are going to be super important here. So if we take a look at this first one, oh my word, emails. If we take a look at this first one here, the first inequality that I have, x is greater than 4. On my number line, I would do an open circle because we're not equal to, and greater is this way. Then we have our x is less than or equal to 6. So on the 6, we're going to be a filled in circle because we're equal to now. And then less than is all the numbers this way. So we're really saying whatever x is, it has to be bigger than 4, but less than 6. And so if we almost think about this graph moving down here on top of this one, all the places that they overlap each other is my final answer. So if I were to graph this one now, on my number line, I can't equal 4, but then I move up and I get to 6, and then I can't go any further than that. Because this is all the space that they overlap. Like almost think about this one coming down onto that one, and then all the stuff that is on top of each other, we take, everything else goes away. And so then the way we write this one is a little bit different. So if I want to take these two inequalities and write them as one, I would say that x has to stay less than or equal to 6, and at the same time, bigger than 4. Now you might think, okay, this sign looks like it flipped, and it did, but x is still bigger because the alligator's eating the bigger, and 4 is still smaller, which is what we wanted. The 4 is next to the smaller, and x is by the bigger. And this is just a little bit more obvious, I feel like, to show that x is between these two numbers, which is what the graph shows. And so whenever we're writing this and inequality, it's really good to write it this way. And it'll always look the same way, where we have this small number here, big number there, and I always have less than symbols. So it should always look like that. Now they might be less than or equal to, but I think you get what I mean. Now, another scenario that can happen. So some other times, like it doesn't work out so nice. And maybe I have something like x is greater than or equal to 4. So on my graph, greater than or equal to, I'll be a filled in circle because we're equal. And greater is this way. And then over here, x also has to be greater than 6. So I'm not equal to, so open circle, but I have to be greater than 6. Now again, and is the overlap. So if I think about taking this graph and putting it on this one, all the spots where they overlap each other is my answer. So really, all this stuff before the 6 can't happen because x has to be greater than 4, but it also has to be greater than 6. So really, it just can be greater than 6. So it's almost like that first graph kind of didn't matter because I had to stay bigger than the 6 overall. Oh my goodness. Sorry, Ellen. Okay, so when I write this one out in correct set builder notation, really all I have is that x is still greater than 6. So when I have an and they're both greater or they're both less, so the symbols are the same, it's always going to be greater or less than the biggest number or smallest number if you're less. The last scenario that we can have, if I have that x is less than 4, so x has to be less than 4, that way, and at the same time, x has to be greater than 6, So just think about that. If you're like playing a guessing game with somebody and you're like, pick a number between 1 and 10, that's what this is. If you're like, pick a number bigger than 4 and bigger than 6, that's what this is. Because really they just have to pick a number bigger than 6. But if I say to somebody, pick a number less than 5 and bigger than 10, there is no number that is less than 5 and bigger than 10. And if you think about putting these graphs on top of each other, they would not overlap at all. So if that happens, where like x is less than a small number and greater than a bigger number, there is no solution. And so my answer is no solution. I don't have a graph because I can't be any of the things. Now guys, all the ones on the inside I think I want to do with you in class, so we won't fill that out yet. But over here, I do want to try some solving examples. Now notice I left some space at the top, and that's because a couple days from now, we're going to do like a review, and I want to do a little review with you up here. So we'll leave that blank. But I want to try these 3 solving and inequalities with you. So all of these and inequalities so far, sorry, this is because somebody interrupted me. Ignore that. They're all set up as our scenario 1 and inequality. So where we have the small number, the x in the middle, and then the big number. And that's how we usually see and inequalities show up. So when we have that, we can really take the and inequality and split it up so that I take my variable with the smaller one. So basically we're just taking the first part of it and writing it over here. And then I take the middle again because that x or that variable goes to both of them, and I write it over here. And then we solve each one. So like if I were to go solve this one, I would add 4 on both sides, and I'd have 1 is less than or equal to m. And then over here when I solve, I would add 4 on both sides, and so m is less than 3. And then I can just smash them back up together. So I put the m in the middle, I bring down this symbol, I bring down that symbol, and I bring down my 1 and my 3. So I feel like that's probably the easiest way to solve it. It's probably the way to solve where you'll make the least amount of errors. But I will show you another way to solve it. So on number 2, what you could do instead of splitting it up and making it 2 equations is you could leave it as 1 equation. But like normally I put in my sides wherever I have an inequality, right? And whatever I do on one side, I have to do on the other. Same thing is true here, but I have 2 inequalities. So really, I have to do 2 sides. And whatever I do in the middle to get the variable alone, I have to do on both ends. So normally when I just write the number twice, here I'm actually writing it 3 times. So like in the middle here, to get y alone, I need to get rid of addition, subtraction first. So I'd add the 4. But if I'm going to add the 4, I have to add it all sides. So here and here. So when I simplify, negative 2 positive 4 will be 2. I bring down my inequality. Negative 4 positive 4 is 0, so I got 3y. Bring down my inequality. And then 14 and 4 is 18. Then I go back to the middle because that's where my variable is. And to get rid of times by 3, I would divide by 3 on all sides. And so 2 divided by 3 is just 2/3. I bring down my inequality. 3 divided by 3 is 1y, and so y is alone. And then 18 divided by 3 is 6. Oh, and I should have shown you how to graph these. So let's graph this one. We don't need to go back and graph the first one. But on this one, on my number line, it should go right in order, like 2/3 is smaller than 6, so I'd have like 2/3 and 6. Something that's definitely in between would be like 3. Something that's definitely before is 0. And something that's definitely after 6 is 10. And then next to the 2/3, this symbol here is not equal to, so open circle. And then next to the 6, this symbol here is also not equal to. And then again, this is scenario 1. So y is all the stuff in between. So I would connect the 2 dots, and it would be all the stuff in between. Okay, for this last one, I feel like, again, this one is the way to make the least amount of mistakes. I feel like when people try to solve it on number 2 like this, sometimes we forget to add it on one end or the other. So with this one, I'm going to solve it like I did with number 1, where I'm going to rewrite 2 equations. So I would have -3 is less than or equal to 6 minus x all over 9. And then I take that middle again, and then I take the end, and I solve each one. So over here, I need to get rid of big divide bar first. So I'd times by 9. And I'd have -27. I don't need to switch my sign because the 9 was positive. So I just bring my less than down. And we got 6 minus x because those divide out. Then I would subtract 6 both sides. So I'd have -33 is less than or equal to -x. Ooh, and then I gotta divide by -1. So I am gonna end up switching my signs. So I'll have +33, switch your inequality, and x. Now when I go to solve over here, we're gonna follow the same steps. Like first I'm gonna times by 9. And so I'll get 27. Then I would subtract the 6 on both sides. So -x is less than or equal to 21. And then I have to get rid of the negative. So I'd switch all the signs like this. And then when I smush them back together, I also have to reverse it because we always want the smaller number first. So I'd actually have to take those 2 and rewrite it as -21 less than or equal to x, which is less than or equal to 33. And then when I graph this guy, I'd have like -21 and 33, and 0 is definitely in between. And something like -50 came before and 50 came after. And because both of these are equal to, my circles are going to be filled in. And because x is in between, it's all the stuff in between those. So good luck, and hopefully that goes okay.